Washing machine. We see this device almost every day in our homes, in our friends' and neighbors' house, and even in the street in many small and big shops and malls. This device is always in front of our eyes. But how many times we asked of ourselves that how this machine is created and works like this? How many times we think about such a thing? Well, whether you think about it or not, this is what we are going to find out in this video. The journey of a modern washing machine begins not with a machine, but with raw, industrial-grade materials. At the heart of the factory, massive coils of cold-rolled, galvanized steel, often weighing several tons, are unfurled and fed into high-speed precision leveling machines. This steel is specifically chosen for its structural integrity and its resistance to the corrosive nature of water and chemical detergents. The first major stage is the stamping plant. Here, monolithic hydraulic presses, capable of exerting over 1,000 tons of force, strike the steel sheets with surgical precision. In a series of progressive dies, the outer panels, the base frame, and the top lid are formed. This isn't just about shaping. The presses also punch out intricate mounting points, ventilation slots, and the entry ports for water and electricity. Every millimeter is accounted for, as even a minor deviation could lead to excessive vibration or structural failure later in the machine's life. As the outer shell takes shape, work begins on the most critical component, the inner drum. Unlike the chassis, the inner drum is crafted from high-grade stainless steel. The metal is first perforated with thousands of tiny burr-free holes. These holes are engineered to allow maximum water flow while remaining perfectly smooth to prevent snagging delicate fabrics. The sheet is then rolled into a perfect cylinder. To join the ends, the factory uses advanced plasma or laser welding, creating a seam that is virtually invisible and stronger than the surrounding metal. One of the most vital subassemblies is the spider, a heavy-duty aluminum or cast iron support bracket bolted to the back of the drum. This component will bear the brunt of the centrifugal force when the machine spins at over 1,000 revolutions per minute. Simultaneously, in the plastic injection molding department, the outer tub is born. This is the watertight vessel that surrounds the stainless steel drum. Using high-density reinforced polypropylene, these massive molds create a tub that is both lightweight and chemically resistant. Many modern tubs are created in two halves and then joined using ultrasonic welding or heavy-duty gaskets and bolts, ensuring a lifetime of leak-free operation. Before the exterior panels can be assembled, they must undergo a rigorous finishing process. They move through a multi-stage chemical pre-treatment, including a phosphate bath that etches the surface to ensure maximum paint adhesion. The panels then enter a pressurized clean room for electrostatic powder coating. In this process, the paint particles are given a high-voltage charge, causing them to be magnetically attracted to the grounded metal panels. This results in a perfectly uniform finish, even on hidden edges. The panels are then baked in high-temperature curing ovens, creating a hard, ceramic-like shell that protects the machine from the humid environment of a laundry room. The assembly line is where these disparate components finally converge. It begins with the heavy-duty suspension system. To keep the machine stable, engineers install massive counterweights, often made of high-density concrete or specialized cast iron, onto the outer tub. This assembly is then suspended within the steel chassis using heavy-tension springs and high-friction shock absorbers. This floating architecture is what allows the drum to spin at high speeds while the outer cabinet remains nearly still. Then comes the powertrain. In modern high-efficiency machines, a brushless DC motor, or BLDC, is installed. In direct drive models, the motor's rotor is attached directly to the drum's shaft, eliminating the need for belts and pulleys, which reduces noise and increases energy efficiency. This is followed by the installation of the plumbing system, the drain pumps, the inlet valves, and the detergent drawer, all connected by industrial-grade EPDM rubber hoses that can withstand extreme temperature fluctuations. The brain of the machine is the printed circuit board, or PCB. This sophisticated microcomputer is installed behind the control panel. It is connected to a complex wiring harness that reaches every sensor in the machine, from the pressure switch that monitors water levels to the thermistors that regulate heat and the Hall effect sensor that tracks the motor's exact position and speed. Before any machine is cleared for shipping, it must pass through the gauntlet of quality control. Every unit is subjected to a hot test, where it is plugged into water and power. Sensors monitor the machine for the slightest hint of a leak, while accelerometers measure vibration levels during a high-speed spin cycle. The electrical system is tested for grounding integrity and electromagnetic interference. Only after passing these rigorous inspections is the machine finalized. The top panel is secured, the aesthetic trim is added, and the unit is cleaned of any factory residue. Finally, the machine is vacuum sealed in protective film and cushioned with shock-absorbing materials for its journey to the consumer. What began as a simple roll of steel has been transformed through high-tech engineering into a precision instrument designed to perform thousands of cycles over decades of service. Well, that's it. You finally realized how a washing machine is created. And not just you realized, I think you can build one after this video. So, like the video and subscribe into the channel because we're worth it.